Hi class, this is the notes for lesson 2-1, use inductive reasoning. You should have already filled out the frame for this lesson, so we're now going to use our inductive reasoning to look at patterns and make conjectures. So our first example right here, we've got 1, 2, 3, 4, and if I keep going, my guess would be that I'm going to say 5, 6, 7, and I could keep going. So my conjecture is the sequence is adding 1 each time. My next pattern is right here, 5, 10, 15, 20, 25, my guess is 30, 35, 40, 45, and so on in that pattern. So my next guess is 30, 35, 40, and then 45. So my conjecture is the sequence adds 5 each time. I'm counting up by 5s. The next one right here, my picture's missing. So your picture on yours should look like this. It has a box and it's got a little corner, a little half circle colored in on the right, and another box and a little half circle colored in on the top. Another box, a little half circle on the left. Another box, a little half circle on the bottom. So my conjecture is that my next box, it'll move back over to the right, and the next one, it'll move up to the top. So really I could have two conjectures here. My first conjecture that I can make is that every term rotates 90, and that should say rotates 90 degrees counterclockwise. That's one possible conjecture, so you might not always have the same conjecture. The second possible conjecture is that we repeat the pattern, and the pattern that we are repeating goes right, top, left, and then bottom. So that's another conjecture we can have, that we're just rotating a pattern. Example 4, there's a picture in here as well, but it did not show up on mine for some reason. So you've got a circle, and then you've got the top half shaded in, so it's broken into 2 pieces. Then you've got another circle, and now it's broken into 4 pieces, and only one of those 4 pieces is shaded in. Got another circle, and that circle is now broken into 6 pieces, and one of the 6 is shaded in. So my guess, so I went 2, 4, 6. My guess is the next one is going to be a circle split into 8 pieces, and we're going to shade into one of them. And then I would double that, and the next one would be split into 16 pieces. So my conjecture is that each time I shouldn't say 8, yeah, 16 would be the next one. No, 10 would be the next one, because I had 2 pieces here, here I had 4 pieces, here I had 6 pieces, then I had 8, so I'm going up by 2 every time. So the next would be 10 pieces and then 12 pieces. So each time the circle is split evenly, I should say, into 2 more pieces. And then we color one of them in. All right, let me move this down here. So example 1, now we're going to look at patterns that are written out in words. So example 1 says, describe the pattern in the numbers -7, -21, -3, -189, and write the next 3 numbers in the pattern. So looking at this, how could I get from negative to 27, or -7 to -21? Well, I could multiply it by 3. And does it work here? Multiply by 3. And here, if I try it out, I'm multiplying by 3 again. So we can, describing it in words, say you multiply by 3 each time. And then if I multiply negative 189 by 3, it's negative 567. That multiplied by 3 is negative 1,701. And that multiplied by 3 is negative 5,103. So those would be my next 3 terms in that pattern. Example 2 here says numbers such as 3, 4, and 5 are called consecutive integers. So they're right in order, they're consecutive. Make and test a conjecture about the sum of any 3 consecutive integers using inductive reasoning. So first, here's the thing, to use inductive reasoning to make a sum, first we must gather data. Got to have some data to decide, what could this be? So let's try some data. 3 plus 4 plus 5. If you add those up, you're going to get 12. 4 plus 5 plus 6. If you add those up, you're going to get 15. 5 plus 6 plus 7. If you add those up, you're going to get 18. And so let's look at these numbers here. So my sum for this first one is 12. Well, let's look here. I could do 3 times 4. That would give me 12. 4. If I do this one, 4 times 4, well, that's not 15. So that doesn't work. Okay, that pattern doesn't work. Let's see here. 4. I could do 4 times 3. 4 times 3 would give me 12. Now if I try 5 times 4, that's not 15. But wait, 5 times 3, that's 15. And 6 times 3, well, that's 18. So I think maybe if you multiply the middle number by 3, you're going to get this last one. So I'm just going to try a bigger number to see if it works. I've got a conjecture. My conjecture here, my conjecture is you multiply the middle term by 3 to get the sum. That's my conjecture. So let's try one bigger one. Just pick a random one, like 50 plus 51 plus 52. And if I add those all up, I'm going to get 153. And if I do 51 times 3, well, that's 153 as well. So I got 153 either way. That pattern worked there. So I can't possibly test every single case, but it looks like I've got the pattern that works. You multiply the middle term by 3 to get the sum. So conjecture is just really a guess that we think is going to work. All right, let's look at example 4 here. And example 4 says make and test a conjecture about the sign of the product of any 3 negative integers. So let's just try some. Negative 1 times negative 2 times negative 3. Well, 1 times 2 times 3, that's really 2 times 3, which is 6. Negative times negative is positive, and another negative gives me a negative 6. Well, really, it's just the sign that the signs are going to determine what our final sign is, isn't it? This is something we've talked about, or you've done before. If I have a negative times another negative times another negative, well, these two will become positive, and if I multiply that by a negative, I'm going to get a negative. So my conjecture is the sign of the product of any 3 negative integers will be negative. That's my conjecture. That's my conjecture right there. All right, let's look at the next one here. So the next one says example A, and this is actually on the next page of your notes. You're going to want to flip your page over. It says, a student makes the following conjecture about the sum of 2 numbers. Find a counterexample to disprove the student's conjecture. So a counterexample, this is something that goes against what we're saying. And this is something that was also on your frame, I believe. Let me double check. Yep, we talked about counterexamples or disproving conjectures on the frame. So it's something that shows that something is not true. So the sum of two numbers is always greater than the larger example. So data for this would be things that show us it works, and some different numbers, trying some different numbers here. So my data, let's see, the sum of two numbers. Sum means add. I want to add two numbers. So let's just pick some numbers. 5 plus 3. Well, that's 8. My sum's definitely bigger. Let's try some other numbers. 100 plus 100. Well, that's 200. That's bigger. I'm using both positive, so I don't think that's going to work. Let's try negative. Let's say negative 5 plus 3. Negative 5 plus 3 is negative 2. Well, negative 2 is definitely not bigger than 3. So there, right here, that one that doesn't work, that's my counterexample right there. So I just need one counterexample to show that it doesn't work. Let's try the next one down. Find a counterexample to show that the following conjecture is false. So my conjecture, the value of x squared is always greater than the value of x. So let's try some numbers. So I will say 5 squared. Let's let x equal 5. That's 25. We're saying the value of x squared is greater. Well, here's my x squared. It's greater. What about a negative number? Let's try negative number. That worked last time using a negative number. What about negative 2 squared? Well, negative 2 squared is positive 4. That's not a counterexample because 4 is definitely bigger than negative 2. So I've got negative, I've got positives. What about a fraction? Let's try a half. 1/2 squared. Well, that's really 1/2 times 1/2, which is 1/4. Oh, wait a second here. 1/4 is definitely smaller than a half. So this is my counterexample. 1/2 squared equals 1/4. And 1/4 is definitely smaller. So there's a counterexample that works for us. All right, so this is the end of the notes for Lesson 2-1. Again, make sure you have your frame filled in. You're only supposed to fill in half of the frame. Make sure you've got that done. Have a good day, and I will see you tomorrow.